Okay, good morning everyone. My name is Chris Von C and I'm here with Subra Kumaraswamy, and today we're going to talk about an API security deep dive. Before we get into the core material, just a couple of general items. We have quite a number of different videos on the Apigee channel on YouTube, and we've also got a number of presentations on SlideShare. So I would encourage you to go check some of that material out, and hopefully you'll find some additional great stuff there. So as I said, my name is Chris Von C. I'm a global architect with Apigee, so I work quite a lot with customers that are implementing the system both in the cloud and on premises. And Subra?
Yeah, hey, good morning. Hey, this is Subra. I am the lead for the product security at Apigee. Like Chris, I work very closely with the customers as well as the engineering folks here to make sure that we can continue to develop security features.
So without further ado, then let's talk a little bit about today's session. We have a pretty packed agenda today. We're going to be talking a bit about API threats and protection and the general threat model for Apigee. We'll be doing a very short demo of some of the OAuth capabilities of Apigee, and specifically the client credentials grant. Then we'll be going into something that's a little bit different for our security webinars. We'll be talking a little bit about operationalization, how you can detect threats to your API ecosystem, and how you can mitigate some of those attacks. We'll be talking very briefly about the process or some of the best practices for securing runtime data, and then we'll get into threat protection from the OWASP perspective and be talking a little bit about the OWASP top 10. And finally wrap up with some great information about SSL and TLS configuration and certificate management in the Apigee system. And we'll have time at the end for questions, so please save those up, and we'll be able to take those for probably the last 10 or 15 minutes of the session.
Just want to kind of set the field here. This is not an API 101, this is going to be deep dive. So we'll quickly dive into the various topics here. First, I want to kind of, before we look into the threat aspects of the APIs, it's very important that as you as an API architect or designer, be able to ask the right questions to stakeholders. The stakeholders include your product manager, who's very interested in make sure that they release the products with security built in, not after the fact. And the business owners is always interested to make sure the product complies, API products complies with the governance requirements. And of course, ops, who is constantly challenged to make sure that they can patch the most recent API vulnerability or be able to respond to any API threats. And most importantly, the developer, who's interested in making sure he can securely expose the APIs to the app developers. So I think the reason why this is important is that once you understand the stakeholders and the threats that are potentially going to be exposed, you'll be able to create a threat model, which we'll walk you through. Let's talk about threat modeling here. So the idea of threat modeling is that you have to do it early in the product design. By doing a threat model, you can identify the vectors of attacks on your API and be able to figure out all the controls, the security controls required to make sure you can protect the confidentiality, the integrity, making sure that there's non-repudiation aspects to it, right? And also be able to mitigate any kind of DOS type attacks. So threat modeling gives you visibility early on in the design. Now, if you ask why is API any different, or if you're thinking about that way, it is no different from your standard web application development. So you should be following the exact same SDLC process. Starting with the threat modeling all the way to testing. So folks who are very familiar with the attack vectors on your web application, would probably be looking at OWASP top 10. So we are going to walk through the OWASP top 10 very soon about the type of attacks on APIs. But keep in mind that OWASP top 10 still applies to API. So if you're already doing OWASP top 10, you're great. You're already ahead of the other folks. But if you haven't, you want to start looking at OWASP top 10 vectors, and we'll give you the details on that. Now, in addition to that, there are certain things that you have to keep in mind when you're exposing APIs. For example, APIs can be abused easily if your API key is stolen. We have seen cases where hackers would decompile an application on an Android and be able to extract the key, and then potentially host the key in Amazon Web Service or Rackspace and attack your API. You should be thinking about attacks through the XML, JSON formats and the payloads. For example, you could, one could inject a XML bomb or a JSON bomb by simply creating recursive activity within your payload. And then lastly, you have to think about token management and key management. When we say tokens, these are OAuth tokens or JSON web tokens that are actually assigned to your applications as part of the authentication. So these tokens need to be protected end to end, which means that you have to make sure the communication is secure between your application and APIs. So now let's kind of get a preview of what a threat model looks like. This diagram here, it kind of illustrates an approach called STRIDE, S-T-R-I-D-E. This is an approach that has been standard in the industry. You can look up on Google to kind of understand what STRIDE offers you. With STRIDE, you can actually model the attacks. You can look at who are the users and services interacting with your APIs, and what type of normal activity occurs in that interaction. For example, a login is an activity, or it could be an attack from a hacker who is trying to get into an API by bypassing authentication. So by making sure that you capture all the entities in your APIs, in your API architecture, for example, your API service, your authentication service that supports the APIs, a developer portal that is supporting your developer services and lifecycle management, a management portal that is allowing the API team to securely expose the APIs. Right? So all of these entities are coming together to deliver the APIs for the app developers. So it's very important that you understand the relationship, the trust relationship between these entities, where you require authentication, where you require authorization, and what kind of authorization. So that allows you to think about the controls, and we'll talk more about that, the controls that you need to have in order to protect the APIs. The big idea here is that once you have an API management platform like Apigee, right, the Apigee Edge, it should take care of all the threats, or if not the majority of the threats, by virtue of the fact that we can provide that security layer that protects API threats. So when you compare from the previous illustration, this one kind of simplifies because your API platform becomes the entry point into your enterprise. It becomes a portal for enterprise. So you don't have to go and secure one API at a time. It gives you an opportunity to have a single entry point to consolidate all the APIs, apply the access control, apply the threat protection for various type of attacks, and then be able to manage your API from a single location. Again, STRIDE is a very commonly used approach. So using the STRIDE approach from the get-go will give you visibility into the attack vectors and the type of security you have to apply on an API. So how does it all manifest in the real world, right? Like once you design your APIs to be exposed to the app developers, you have to deploy this platform, and you have to make sure that you have isolation between various entities interacting with the API platform. These are your apps, your mobile apps, sometimes your partners who are connecting to your API gateway for various reasons. For example, you may be exposing a payment API to a merchant if you're an e-commerce provider. You may also have developers who are both inside the firewall, meaning your employees and contractors, who are more trusted than developers who are outside. A third-party developer who is kind of opting in through your developer program. So you're going to have a trust issue there. So be able to create a deployment architecture and be able to identify what are the different access requirements for each of those users and services interacting with your API platform. Allows you to isolate the threats and be able to give access to the right actors. Like for example, your internal developers will have more access to your APIs by virtue of being within certain network. But that's not the you don't want to rely on that completely, because you want to still make sure you use role-based access control. But the fact that you have internal developers having full access to your APIs means that there is a potential opportunity to leak that to external developers. And making sure that you have a TLS-based protection for all your communications, both from the apps to the API gateway, Apigee Edge, and from Edge to the backend services. Okay, so and we talked about threat protection and various access control that you can think about. The way you should look at this is that every single entity, in this case, a user or an application, will require authentication, authorization, and potentially auditing, right? So be able to identify who the user is and what kind of authentication. Is it authentication against your corporate directory, against your single sign-on provider? Perhaps it's your ADFS or a third-party INT provider like a ForgeRock or Ping. Are you going to use OpenID Connect, or is it simply going to be a password grant-based OAuth authentication? In some cases, you may have a social login, so that you can let users to log in using the social IDs. So, and if you identify for every single entity interacting with your platform for the three areas, the authentication, authorization, auditing, that provides you the access control layer. And so, and this way, you can make sure that from a application exposure policies, that these users are coming in and meeting your requirements. In some cases, you may have third-party developers who are authenticating through your external INT providers, and you may want to call it out, right? So again, the goal for as part of the early design architecture is identify all the services, all the players, what access control requirements they have, and be able to meet that using your API platform like Edge. One other key requirement here is that every application requires some sort of authentication authorization. And OAuth is the OAuth, which is in flavors of OAuth 1.0a and 2.0, is the most commonly used industry standard protocol. In today's demo, we won't be going through all the different grant types. OAuth has 4 different grant types, and we have a separate webinar. You can check out our YouTube channel just on OAuth. It's a session by itself. But today we're going to show you a very simple demo of how you can enable an OAuth with your application by using a grant type called client credentials. So what we have here is an application called Postman. It's a Chrome extension. It's going to act like a API client. And we have an application called Hello World. And it's simply going to take, this application is going to take a bearer token. So in order to have a bearer token, first you need to make sure that we can generate a token. And so this particular activity here, which talks to the Apigee Edge, is actually being handled by the Edge policy. And simply we are going to be calling a grant type here, which is the client credentials. First, we're going to go and generate the token. Okay, so we've already preloaded this with the key, which is the API, so the app key and an app password, and that's base64 encoded in the request. And then we got a response back with the access token. So this is simply a client credentials grant that we executed. So we're going to take the access token that we got from the first call and go to the application called Hello World, which is expecting a token here. So we're going to simply cut and paste the new token, and boom. Okay, so we got the application that accepted the token that was generated. And the reason why this is important is that you don't want an application to store a username and password. You would rather have a key and a key secret, which allows you to get the token from the gateway Apigee Edge. And Chris will talk a little bit about how we can protect that and how we can respond to any kind of compromise in a few seconds.
So the key things then about this, I think if I understand correctly, are that when you generated the token, we actually executed an OAuth policy on the Apigee system itself that took the base64 encoded credentials that we provided, checked those against Apigee, and then generated the token. And then when we actually invoked the Hello World app, Apigee validated that token against its repository, checked the keys and so on to make sure that not only were the keys valid, but also that we had access to this particular application. Is that
exactly,
right?
Exactly. And in this case, it happens to be a test organization. So this is going to be, every organization in the Apigee Edge has, ability to have keys scoped to your organization and not exposed to other orgs. And then we'll quickly jump back to these slides here. All right, so now that we talked about the basic access control, we're going to talk about the operation considerations as you're thinking about API deployment.
Right. So in a lot of the security webinars that we do, we talk a lot about the capabilities of Apigee in terms of being able to protect against threats, generating tokens and validating tokens, as we just saw, being able to look at various different threat vectors and mitigate those in some way. So we're going to take a slightly different perspective on Apigee security in this part of the presentation and talk about what you as a security administrator, you as an operator of the Apigee system can do to kind of help protect the overall security of the system. So when you're thinking about security from this operationalized perspective, then obviously there's a lot of different ways to look at security, and each API security stakeholder that we've talked about before will have a different perspective on security, what needs to be done, what needs to be protected, and so on and so forth. And certainly from my perspective, a lot of the customers that I've seen are all unique in their particular requirements. So the system provides a lot of flexibility in that regard to address various types of threat vectors and requirements and so on. Some of the questions that you might think about, for example, are things like how you can structure your Apigee instance to allow for the correct level of spheres of control so that you can implement appropriate role-based access control and protect your API assets from just internal threats, people in your operations team or something along that line. But there's also a really critical need to be able to determine if an attack is in progress or if a key's been compromised, for example, or something along that line. And to really understand what it is that you can do to try and mitigate threats that you see like that. In a lot of customer situations, we see a need to be able to store credentials for back-end systems that we're accessing through the API layer. And so being able to manage those securely is also a pretty critical aspect of things. There's obviously a lot of other questions here. We're going to focus in today's session on the first few of these, and we're going to save some of the other ones that you see here for future API security deep dives.
Yeah, and it's very important as an organization to be prepared for any kind of breaches, right? So this is going to be, apart from preventing it, it also helps you to understand how you can respond.
Right. So let's start out by talking a little bit about Apigee's capabilities to enforce spheres of control, if you will. Trust domains, I guess, would be a good term. As you probably already know, if you've had an opportunity to look at Apigee, we have this logical partitioning concept that we call organizations and environments. You can think of organizations as being containers for all things Apigee. And so API proxies, developer definitions, application definitions, and things along that line all exist in the context of an organization. And organizations are self-contained. So when you create multiple organizations within an Apigee instance, each one of those is logically separated one from another. So users in one organization can't have access to resources that exist in another organization. Along similar lines, we have a concept of what we call environments, which allows for a certain amount of resource sharing in terms of developers and application definitions and things along that line. And it also gives you a shared API team that can manage all of the different environments. But environments allow you to partition API proxies in different ways so that you can either emulate your software development lifecycle with development and test and production environments, or you can partition environments to meet whatever specific needs you might have for gaining spheres of control, if you will, within your particular organization. So by taking a little bit of time when you first put together your Apigee system and thinking about how you can use organizations and environments to partition resources, you can really streamline the definition of spheres of control and the enforcement of access control rules and so on using role-based access control and other mechanisms so that you can minimize the potential threats to your system from both internal and external actors.
I think one point I want to add here is that a lot of times developers, DevOps, they always wonder, how do you make sure that the API keys are isolated from each environment?
Mm-hmm.
So, a dev environment may have more access to API keys, and because, you don't have sensitive data, versus, when the application moves to the production, the keys are going to be different and going to be isolated. Only the folks who need access have access.
Right. So. Right. Yeah, and Apigee provides abilities at both the organization and environment level to completely separate keys, so that even though you may have a common application definition, you have a lot of good facilities for locking down exactly what resources in what environments that particular application can access. You may have seen back in 2012, there was a webinar that was done by a guy named Tom Pohl in the Central Iowa Linux Users Group, where he talked about his experiences in hacking the Nike Fuel Band. And I think it was kind of an interesting and enlightening webinar in that he talked about what certainly we would think of as being pretty modest tools and techniques for determining security credentials and so on, things like Burp Suite and Little Snitch and things along that line. And what he was actually able to do is to completely hack the applications around the Nike Fuel Band and to expose API credentials and other information that was used by that, and was actually able to issue API calls to the Nike backend and retrieve information about his usage of the Fuel Band and so on and so forth. And of course, obviously, he posted this on a webinar, so now lots of people have this same capability and can go off and use the APIs in new and interesting kind of ways, right? So the question that you would ask yourself then is, if something like this were to happen to you, what would you do about it? And how would you even know that such a thing had happened? The Apigee system provides a lot of analytics capabilities that can help you determine when things like this have occurred. For example, it gives you capabilities to determine what source addresses requests are coming from, or what the frequency of certain types of requests are by certain applications, and things along that line. So you can look at these things and kind of watch the trends over time, and if you start seeing situations where a particular user's data is being accessed an inordinate amount of times, or there's unusual activity coming from what would normally be a US-based application, for example, then you can start taking action on that. And those actions are kind of multidimensional. The kind of brute force nuclear option is to invalidate the API key. And Apigee actually provides a number of different options for not only totally regenerating API keys so that the current key can never be used again, but also for temporarily revoking and then re-enabling keys as well. So if you need to, you can revoke the key, make some changes to your application, or do what you need to do, and then re-enable the key again. You've also got some capabilities to manage access tokens, which we had seen from the earlier demo. And that's particularly important because we often run into situations where access tokens that represent a particular user's access on a particular device have been compromised through something like a man-in-the-middle attack or something like that. And so once you recognize that these tokens are being used in unusual ways, then you can actually take action to completely invalidate those tokens. If you know the token, you can actually just use the Apigee Management API to invalidate the token either permanently or temporarily. Or if you would prefer to do say a mass password reset for all of your users, for example, you can actually go so far as to add logic to your application or your API proxy to check inbound users, validate their token, determine when it was issued, and then automatically invalidate tokens that were issued before the point at which you believe that the attack started. So that then would force a user to log in, for example, or force an application to revalidate itself, reauthenticate itself. And then at that point, you have lots of different options. You can look at the particular application, you can look at the source IP address, and you can take some action based on that. So the combination of having management API calls plus things that you can actually do in the proxy is a pretty powerful mechanism to allow you to mitigate some of these attacks. So what we'll do now is we'll spend a couple of minutes talking through some mechanisms that Apigee provides for handling compromised applications. So we'll switch over to our friend Postman again. And you can see here that we have a number of different API calls that we've created for doing things like revoking keys and re-enabling keys and so on. So let's start with key revocation. You can see here that we're issuing an API call to Apigee's management endpoint in the cloud, and we're accessing a particular organization, a particular application, and a particular key. If we were to scroll this over, you could actually see the key here in the API call. And we're indicating that we're revoking the operation. So this key happens to be for the application that we saw before, Hello World. And if we reissue that call again, you can see, the access token is expired. So let's regenerate another one. We'll take this access token. We'll plug it into Hello World. We'll send it, and now we're back to Hello World again. So if we were to revoke this key, you can see we got a 2 of 4 not content status back, which basically indicates that we successfully revoked the key. And then if we go back to this application again, you can see that we actually get a message that the key is not approved. Now these particular error or messages that we're seeing here are kind of the default Apigee generated messages. You obviously have the ability to modify these so that you can return a 401 unauthorized status or a 403 forbidden status or something that makes sense from your perspective as part of your API. So we've actually got a similar mechanism for re-enabling the key. And if we use basically the same call but with action equals approve, we get again a 204 no content status, and then when we go back to our application again, the access token expired. But you can see that the key was re-enabled, and we actually got to the point where it checked the access token expiration for that key. And we've got similar mechanisms also for revoking tokens, approving tokens, and so on and so forth. So you actually have the ability to capture a particular token, perhaps from Apigee Analytics, and to invalidate that token immediately. And as we said before, we've also got mechanisms in the system to allow you to dynamically invalidate tokens. So let's say, for example, that you set up a blacklist of users whose account had been compromised as the result of a data breach, for example. Mm-hmm. And you wanted to be able to force those users to change their password when they use the API next. So what you could do is just add a small amount of code to your API proxy, and it could check that blacklist, and then inside the context of the proxy, it could invalidate the current token. And then once that token is invalidated, you can return a 401 unauthorized, which will tell the consuming application to revalidate credentials. And at that point, obviously, then the user has an opportunity to change their credentials and take whatever action that you think is appropriate as part of that mitigation.
Yeah, and we have seen customers who track their devices as device ID. For example, you could store the device ID in the back end of the service and be able to say that, when these IDs are compromised, you can put a flag next to it and block it on the fly.
Absolutely.
All right, so now switching back, how do you secure sensitive data that is stored in the platform? So Chris,
Yeah. In other webinars, we've talked about a few different techniques to do this, and one of the things that we highly recommend is the use of something called the Apigee Vault, which is an encrypted version of our key value map. There's actually two different types of Apigee Vaults, one of which is environment specific and one of which is organization specific. I think generally our experience has been that most customers tend to use the environment specific vault because they want to be able to store credentials for different backends for different parts of their application development lifecycle. And the environment level vault would allow them to do that quite effectively. So the key point here is that we're not actually encrypting the data itself. The entire vault infrastructure is encrypted and secured inside the Apigee ecosystem, inside the infrastructure. So we can actually take a really quick look at what that looks like. And if we go over to the Apigee system, then you can see here that we have a number of different proxies, and we're actually going to take a look at the vault example. I'm not going to actually run this, but I'll kind of talk to you about how this actually works. The interesting thing about the vault is that it's a write access vault from the outside and a read-only access from the inside. So typically what you would do is create the vault and populate it with credentials from the outside, but you actually have no ability to read those credentials back from the outside. And so once those credentials are set, an operations person, for example, or somebody else who might have access to the management API can't actually go back and read those credentials again. Okay? But a proxy that's running in the Apigee environment can actually read those credentials using Node.js and then go ahead and use those credentials as part of calls it would make to back-end systems.
And a lot of the developers are used to writing code and checking into GitHub. One of the common mistakes is that you end up storing in the passwords and secrets in the code, and you accidentally expose yourself.
Yeah.
So by using the Apigee Secure Vault, you don't have to do that. Now the code can go at runtime, fetch those credentials based on the org scope or environment scope. So that by eliminating any need to embed keys or passwords into the source code itself.
Mm-hmm. So you can see here in the code, we've got a couple of key pieces here. This particular Node.js service is just getting some general information about the environment, and it's actually looking at a payload that we can take a look at in Postman. So for example, if we take a look at the call, where is it? Here we go. This is the request that we made to actually add the credentials to the vault. And the request that's actually being made inside the Apigee system itself basically emulates the same mechanism. It specifies both the name of the vault in question and also the actual key of the credentials that we're using. And of course you can have multiple different sets of credentials, all of which have a different key. So if we were to go to the Node.js code then, we can actually see that we're looking at this this payload that's coming in from the system. It's actually being set right here. So we're accessing vault name my credentials with keys of target 1 creds. And then if we go to the Node.js code, we're actually pulling out bits of information from that and calling a function called getCredentials, which actually makes the vault call. So here's our access to the Apigee Vault. We happen to have code in here that allows us to process multiple requests for keys at the same time. And when we actually do find the key, then we just set that as the response to the API request. And so that comes back as part of the response message in the API proxy itself. And then from that point, you can pick out the credentials, you can use those in making back-end calls and so on and so forth. So this is a really nice way to handle back-end credentials because it's totally secure, not accessible from the outside once you set those credentials. And it's really pretty straightforward to access this.
So we'll switch gears a little bit now that we know we've talked about the access control and how you can securely pass credential information to your APIs. We'll spend a couple of minutes on the threat protection layers. We spoke briefly about the OWASP top 10, which normally involves SQL injection type attacks or process scripting attacks. So let's talk about, and we'll show a quick demo of that too. If you're concerned about these attacks, first thing you want to make sure is that your application is designed to handle these attacks at every layer, right? So first layer is going to be the Apigee Edge. Doesn't mean that because Apigee Edge is providing these protection doesn't mean that you don't have to do it in the API. So it's always good to have layers of security. We call it defense in depth strategy. So the most commonly exploited vulnerability on the internet today is the SQL injection attack. What that is that if you're not doing any input validation or you're not sanitizing the parameters from the URI or payload, And if you're passing it directly into a module that's making a call into the SQL service, potentially the hackers can manipulate it, add their own variations to either go and read more than your application is supposed to provide the user, or be able to modify the records. So it's a very commonly used attack. So we have a protection policy that I will demonstrate how we are using it. And of course, there are other things to think about here, like the process scripting attack. Here it's really important to make sure that by using a JSON transformation in the platform, that you're doing standardization, so you can drop JavaScript calls that are not intended for the APIs. The other thing I want to call out is the sensitive data exposure. This is the area that a lot of the PCI and HIPAA customers are very concerned about. So you want to make sure that as the data is moving through the API platform here in Apigee Edge, it is protected through what we call data masking feature. Data masking feature allows you to make sure that any of those sensitive data that includes credit card information, it could be a patient record for healthcare, those are not stored in any ways, right? It's not stored in the logs, it's not stored for debugging. So it makes it completely secure as the payload moves through the platform. So we'll do a quick demo of the, given that we are running out of time here. And I just want to cover a couple of things. There are various policies in the platform. This can be used as either through the UI or through the management API. The most important policy that everybody should be thinking about is the rate limiting policy. It allows you to slow down the hackers. If someone is doing a DOS type attack on your API or trying to harvest information because you don't have authentication, this policy allows you to slow down the attacker by setting limits. So it's a very important tool you can have. Last year, I think Snapchat got compromised because of the fact that they didn't have a rate limiting policy. Okay, so we'll do a quick demo. I'm going to show how to protect your APIs from a SQL injection attack. If you see here, there is the client called SQL injection attack test. What this is that we're going to be injecting certain parameters, which will drop the these parameters are going to be injected into the header. For example, there's a drop table orders. So this is an API where you're trying to manipulate by injecting a drop table syntax into the URI. And we have set a policy in the Apigee platform to look for these keywords, and we have a bunch of rules that we offer as part of the standard template, which can be used out of the box. And I'm going to do a quick run of this test here. I think the screen's so now we're executing the command. Okay, so basically you're getting error back from the edge saying that the threat was detected. And again, these are this message can be customized for your application. But the key is that we have there's a regular expression policy that allows you to drop certain type of API calls as soon as it matches a SQL injection type attack. Okay, so we'll quickly talk about some of the basic stuff you need to think about when you're securing the communications from the app to the app APIs. First and foremost is securing your inbound communication. So Apigee Edge provides two-way SSL support, two-way TLS with very configurable ciphers, especially in light of the recent attacks like Poodle, Freak, Heartbleed. You want to make sure that your SSL protocol is configured with the right protocols. So disable SSL 2.0, disable 3.0, make sure you're running TLS 1.1 or 1.2 with the right ciphers. So we provide that out of the box in terms of configuration. So making sure that especially when you're communicating to a partner, you want to enable two-way TLS because you can authenticate the clients. In a two-way TLS, not only the client is authenticating the server, which is the Apigee Edge, and the Apigee Edge is also authenticating the client. So you have a very high, strong authentication. In addition to that, you may be enabling whitelist or blacklist IP addresses. So you can have a layer of network level access control, and on top of that, you have the application level access control using TLS. And we do that, and we can do that very easily through a XML construct we call the virtual host. And in this slide, you can see you can explicitly call out the ciphers you want to support. So these ciphers, again, your organization may have a standard you may want to comply with, but by default, you want to go with the more secure ciphers. And you have option to call, use the key store and trust store. This is where all the certificates for two-way TLS are hosted. So if you have a client certs you want to manage, those are uploaded into your key store and trust store. And you can also show what protocols you want to enable by calling the protocol. So typically this particular configuration is done once, right? And once you're done, it's there for all your proxies. And same thing goes up, to the outbound security here. Outbound meaning communications between the Apigee Edge to your backend or API services. We sometimes call southbound. Here again, you want to enable one-way or two-way SSL or TLS, and these are highly configurable. And you configure that through HTTP target connection construct with SSL information. Again, here you can configure the ciphers, the protocols, and you can explicitly drop the ones that are weak. The goal for us is that once you enable the SSL on the inbound and outbound, you have an end-to-end communication that's secure.
So as Subra said, there's a key part of enabling effective security for SSL TLS is to have the appropriate keys and certificates in your key store, and also the certificates of your partners in the trust store for two-way SSL, right? And obviously, this introduces a consideration of managing certificates themselves. And so Apigee actually provides a couple of different mechanisms for doing security management or certificate management. If you go to the management UI and pull down the administrative page, you'll see that there's an option there for certificate management, and that gives you the ability to at least check your certificate expiration dates and scopes and whatnot, so that you can anticipate when certificates are about to expire. You can get a new certificate and then add that to the key store or trust store as appropriate. And that same kind of facility, and actually much more, are available through the management API as well. So you can use the management API to insert certificates, and in the case of the key store, keys as well. You can use that to retrieve information about the certificate. You can change certificates, delete certificates, and things like that, all through the management API. So it's a pretty straightforward mechanism and a very powerful way to, in a substantially automated fashion, actually build some scripts to manage certificates in a straightforward fashion.
Yeah, DevOps love to automate, and they're constantly using Chef or Puppets. So having API to expose all sorts of lifecycle management for certificates really helps DevOps to automate their certificate management.
Very true.
All right, so I think we come to the summary. We come to the end of our presentation. Just want to kind of recap. Again, you want to start with at the very first engagement with any developers with a threat modeling exercise. Allows you to think about all the threats, internal, external, and authenticated, unauthenticated, and allows you to think about the controls that you need to have. And this is where Edge will help you to make sure that you can enable those controls through policies and some things like what Chris walked you through for a secure vault. And making sure that you're protecting the backend, and that's the goal here is to make sure that even under a DOS attack, you don't want that to go all the way back to your APIs. By having a layer, in this case Apigee Edge, you can drop those DOS attacks or rate limiting, using rate limiting policy. Any of those, sometimes inadvertent benchmarking can trigger that. And again, everything is available as a policy, and you can configure through UI or configure through a management API. And once you get beyond the threat protection, then making sure that you have the right access control that allows you to secure your backend from any kind of privilege escalation. So having a authentication, authorization, auditing enabled at the Apigee Edge layer gives you the protection from any kind of authenticated attacks. And then as Chris walked through the in terms of certificate management, having a really good design with end-to-end security. Here is where we enable TLS for inbound and outbound, and having that automated through APIs will ensure that your APIs are secure end-to-end. And don't forget about response. It's not about just prevention and detection. It's also about responding to any kind of breaches. So by being prepared, and this is where the configuration becomes your friend. So last time you had an attack like Freak, we simply went and reconfigured our endpoints to drop the weak ciphers, right? So having a configuration-based security approach will help you to quickly respond to any new vulnerability that is discovered. So with that, we will move on to the Q&A section.
Okay, so we actually do have a few questions here. The first one is, do we have a list of keywords that are checked against? And I'm guessing that this relates specifically to the SQL injection attack policy that you described, right? The documentation has a very, very basic regular expression that checks for all the major SQL keywords, insert, select, drop, alter,
Update.
things along that line, update, and so on. And that will cover a fairly significant number of cases. If you have some specific things that you'd like to be able to guard against, inserting stored procedures, for example, or something like that, then extending the regular expression to be able to check for those things is pretty straightforward.
And please feel free to check the Apigee community site. We will be posting some of the the templates there. Again, this is an area that can be fine-tuned further than what we have by default.
Yeah. Okay, so the next question we have is a question actually about pricing. There's actually a couple things that we can talk about here. Apigee is very committed to supporting the developer community, so we actually provide a free version of Apigee that we call Apigee Developer. And you can request an account. You can get it very quickly. You can actually experiment with it. And we actually do have some developers that are running moderate amounts of traffic through the free system. There are some restrictions. Obviously, you don't have quite as much flexibility as what we've shown here with the paid product. But for a lot of cases, it's actually a really great way to get a hands-on sense of what Apigee is capable of. And most of the facilities that we've talked about today are actually available in the free product as well. For the paid product, obviously, we'll work with you, very closely based on your specific requirements, whether you're looking for cloud or on-premise, how many transactions you'd like to have per quarter, and so on and so forth. And so, if you'd like to hear more about that, we could certainly put you in touch with someone who can talk about that in more detail. The next question we have has to do with the client credentials grant. How can we use the client credentials grant type with JavaScript HTML5 applications where the client secret cannot be maintained and client authorization is not required? So this is actually a really good question. The client credentials grant in OAuth actually relies on having the API key and shared secret represent the application. So those are really the credentials that you're authenticating against, okay? So when you're working with JavaScript and HTML5 applications, you've got a huge challenge in that these things are inherently insecure. And so if your expectation is that you'll be able to use a client credentials grant to manage this authentication, that's obviously quite a challenge because it's super easy for somebody to just go in and take a look at your application, right? So OAuth actually defines something called the implicit grant, which is a variation on some of the other grant types in OAuth. It does provide an API key so that you can actually track applications and what they're doing with your API and so on. But it primarily relies on user credentials to do its authentication. And so using the combination of API key validation in the Apigee system itself and also user credential validation using some of the identity providers that Subra had talked about early on, you can ensure that you've got an authenticated user and that they're authorized to use the system. But definitely, if you're writing HTML5 applications, I would strongly consider using the implicit grant rather than the client credentials grant because of the inherently unsecure nature of the system. Okay, so the next question is, what is the regular expression used to protect from SQL injection? It's actually on our documentation site, apigee.com/docs. If you do a search for the regular expression protection policy, then you'll see that there's a list of all of the different regular expressions that we might potentially suggest. Obviously, your requirements might be slightly different. The expressions that we recommend in the documentation are fairly straightforward, somewhat simplistic, may not necessarily cover all the cases that you might have, but they're a good starting point, and they'll catch a pretty significant number, I think, of the injection attacks or JavaScript injection attacks that you might encounter. Another thing that's important to recognize here is that not only do you have the ability to check the payload, which is what Subra did in his presentation, but you also have the ability to check headers, query parameters, form parameters, parts of the path, and so on, using the regular expression policy as well. So you can get a good comprehensive coverage on all the API calls that come through your system.
Great. And we have one more. Keep the questions coming. Has the Apigee Edge platform been audited by a third party against ISO or PCI standard? If so, can the audit results or summary be requested? Okay, great. Yes. So there are two parts to the answer here. One is we are PCI certified in the cloud. So we have a PCI offering specifically for those and HIPAA compliant for those folks who want to host any kind of APIs that require PCI and HIPAA compliance. We also test our product using third-party pen testers. You can call them white hats. So we subject our platform to these tests on a regular basis. And for our customers, we offer both the reports. We share the PCI compliance report called AOC, Attestation of Certification, as well as we share the pen testing report, which talks about how the test that was done against our platform and all the remediation that has been done on the platform. Okay, I think that's kind of the last question here.
So with that, thanks very much for your time. We appreciate your attendance, and if you have any other questions, then by all means drop us a line. We'll be glad to help. Take care. Have a good one.
Thank you.